Today, we, today we want to discuss about the terms speed, average speed, instantaneous speed, uniform speed, non-uniform speed, and velocity, average velocity, instantaneous velocity, uniform velocity, non-uniform velocity. Today we want to discuss all these terms. Speed. Speed means if your body traveled 10 meter in 1 second, then the speed of your body is defined as the rate of displacement, rate of distance traveled by time. This is known as rate of distance traveled. Next one, it is also represented by delta S by T. Delta S by T. Now, the unit for this speed is meter per second. It is a scalar, or it can be represented as meter second inverse. Meter second inverse. Now, for example, the speed of a body here, a body traveled 10 meter in 1 second. That means here speed of a body 10 meter, distance traveled is 10 meter by 1 second. That means 10 meter per second is the speed of that body. Speed of that body. For example, if a body traveled 100 meter in 5 seconds, what is the speed of the body? Here speed is equal to distance traveled 100 meter by total time taken 5, we get 20 meter per second. Here it is a scalar quantity. In which direction the body is moved is not mentioned. That is why it is a scalar quantity. Next one, average speed. Average speed, for example, a body travel the total distance. For example, it is defined as the average speed is equal to, it is represented by like this average speed, it is equal to total distance traveled by total time taken. That means delta S by delta T. This is the average speed of a body. For example, a body traveled 10 meter in 2 seconds. In next 2 seconds, it traveled 20 meter. Then what is the average speed of the body? It is also written as first interval. It is T1, I say. It is T2. S1, S2. S1 plus S2, total displacement by total time taken. We get the average speed of that body. That is the formula for average speed. Next one, uniform speed. Uniform speed. Or not uniform speed. Instantaneous speed, we want to know about instantaneous speed. For example, a body is moving like this on its path at a particular instant. The velocity of a body is say 10 meter per second, for example. That is known as instantaneous speed of that body. Instantaneous speed of that body. Instantaneous speed means the speed of a body at a particular instant of time. The speed of a body at a particular instant of time. Here it mathematically is represented like instantaneous is equal to limit delta t stands to 0, delta s by delta t is equal to ds by dt. It is represented like this. We do problems by using this formula later. Now, at a particular, the speedometer of a vehicle, generally speedometer of the vehicle, scooter, all those things have a speedometer. That speedometer measures the instantaneous speed. That means at particular instant, the speed of a body is given by that speedometer. That is the instantaneous speed. Now we want to know about the uniform speed. Uniform, for example, a body in first second it travel 5 meter, in second it traveled 5 meter, in last 1 second it traveled 5 meter. That means if a body travel equal distances in equal intervals of time. For example, this is delta S. Yes, it is delta T. Interval, time intervals, it is the displacement, delta S. If the body covers equal distance or travel equal distances in equal intervals of time, then the body is said to be moving with uniform speed. Next one, non-uniform speed. For example, in 2 seconds it traveled 5 meter, in 1 second 5 meter, in 3 seconds it traveled 5 meter. Here time intervals are different, but distance travel are equal. At this time, this is the non-uniform speed. If a body covers equal distances in unequal intervals of time, however small these intervals may be. Next one, for example, a body in equal intervals of time traveled 5 meter here, 2 meter here, 3 meter here. At this time also it is known as non-uniform speed. If a body covers unequal distances in equal intervals of time, then the body is said to be moving with the non-uniform speed. For example, uniform. Now, instantaneous we do some problems about this average speed, all those things. For example, if a body traveled half of the distance, for example, of d, total distance traveled is d, I say here d by 2, half of the distance with velocity v1 and speed v1 and the next half with the speed v2. Then the average speed of a body is given by, S1 plus S2 by T1 plus T2. This is the average speed of a body, formula for average speed of a body. Now, d by 2 S1, it is S2 plus d by 2 by T1. T1 means here T1 is equal to distance travelled by speed. T2 is equal to distance travelled by speed. Now it becomes d by 2v1 plus d by 2v2. If you simplify this one, d common in the denominator, 1 by 2v1 plus 1 by 2v2. dd cancel. Here we get after LCM 2v1 v2. Here v2 plus v1 denominator. In the denominator we get this one. Here it becomes 2v1 v2 by v1 plus v2. This is the average speed of the body. If your body covers half of the distance with velocity speed v1 and the next half with the speed v2. This is the average speed of your body. Here this formula can be written. This can be if a body traveled, similarly, if a body traveled 1/3 of a distance, d by 3, and d by 3, 1/3 with the speed v1, another 1/3 v2 and another 1/3 v3. Then the average speed of a body is given by V average S1 plus S2 plus S3 by T1 plus T2 plus T3. Here T1 d by 3 v1, T2 d by 3 v2, T3 d by 3 v3. We substitute these values in this formula. D by 3 plus d by 3 plus d by 3 divided by T1 d by 3v1 plus d by 3v2 plus d by 3v3. D by 3 is common. We get 3 here. By d by 3 here also common. We get 1 by v1 plus 1 by v2 plus 1 by v3. D by 3 cancel. Now the average speed becomes 3 v1 plus v2 v3 divided by v1 v2 plus v2 v3 plus v3 v1. This is the average speed. If a body travel 1 by nth of the total distance, next one by v1, and next one by nth of the distance v2, so on, then this formula becomes general formula. V average. N here, how many? Nth means n, 1 by nth of the n here we get 1 by v1 plus 1 by v2 plus so on plus 1 by vn. This is the general formula. Here this formula becomes 3 by v average is equal to 1 by v1, 1 by v2 plus 1 by v3. First one becomes 2 by v average is equal to 1 by v1 plus 1 by v2. Like this, the average speed of a body we can find. Here, this is the average speed of a body. Next one, in another way, average speed is determined like this. For example, if a body another example for average speed. If a body traveled from A to B and A to B to a distance D, then returns to A, what is the average speed? For example, with a speed v1 in this direction with a speed v1. Then here also we get the average speed is equal to s1 plus s2 by t1 plus t2. s1 plus d by, here we were t1 is equal to d by v1, t2 is equal to d by v2. Here d by v1 plus d by v2. After simplification, here we get 2v1 v2 by v1 plus v2 here. This is the average speed of a body. Next one, next example for average speed. Another one, if half of the time, if your body moves half of the time, total time taken to of the journey, total journey time is equal to t, for example. Half of the time with the speed v1, another half with the speed v2. It is t1, it is t2. Then average speed s1 plus s2 by t1 plus t2. T1 plus T2. Here, S1 means S1 is equal to V1 T1. That means V1 T by 2. S2 is equal to V2 T by 2. Here we substitute S1, S2. V1 T by 2 plus V2 T by 2 by T by 2 plus T by 2. Here, V1 plus V2 by 2 here. This is the average speed of the body, average speed of the body. Now, we want to find out the instantaneous speed of a body. For example, here we use the differentiation. For example, the displacement of a body or distance traveled by a body is given by S is equal to 2t square plus t. Here this equation gives the distance traveled by a body. Find out speed, instantaneous speed at t is equal to 2 seconds. We want to find out the instantaneous speed at t is equal to 2 seconds. Now we have a formula, instantaneous speed is equal to ds by dt. We differentiate this equation, ds by dt is equal to 2t square plus t here. This differentiation 2 into differentiation of t square 2t to the power 2 minus 1 plus d of t by dt. It is equal to 4t plus 1. Here we use the differentiation formula dx to the power of n by dx is equal to n x to the power of n minus 1. This formula here we use. Here power of t square is 2, that means 2 minus 1, n minus 1. Power comes to the front of this t. Now, we want to find out the speed at t is equal to 2 seconds. T is equal. Now we put a t value here. 4 into 2 plus 1. That means 8 plus 1. That means 9 meters per second. It is in meters. For example, that is the equation is in meters. Then we get the instantaneous speed of a body. Now, example to find that one. First, velocity. Here we want to know about the velocity. What is meant by the velocity? The rate of displacement, velocity, is equal to displacement by time. It is unit is meter second inverse. It is a vector. It is a vector. That means delta r bar by t. It becomes r bar by t. Yeah. Next one, mod. Generally, it is a vector. It is a vector. Next one. For example, a body travelled 10 meters towards east in 5 seconds. The velocity of a body 10 by 5. We get 2 meters per second towards east, because it is a vector quantity. Because it is a vector quantity. Next one. Average velocity. Average velocity means that it is defined as the ratio between total displacement to total time taken. That means V average is equal to delta r bar by delta t. This is the average velocity. Otherwise, S1 bar plus S2 bar by T1 plus T2. We write like this. It is a vector sum. Next one. This is the average velocity. Next one, instantaneous velocity. It is the velocity of a body at a particular instant of time. It is the velocity of a body at a particular instant of time. Now, at particular instant of time means this is the, at this particular point, what is the velocity? That is the instantaneous velocity of a body. Now here we also mathematically instantaneous is equal to limit delta t stands to 0, delta r bar by delta t is equal to dr bar by dt. This is our instantaneous velocity. Next one, uniform velocity. If a body travelled similar to the uniform speed, a body travelled equal displacements in equal intervals of time, then the body is said to be moving with a uniform velocity. Another way, non-uniform velocity means if a body covers unequal distances in equal intervals of time. 1 second, 1 second, 1 second, 1 second. Now, if the unequal distance travelled by the body in equal intervals of time, then the displacement, not distances, if body covers unequal displacements in equal intervals of time, then the body is said to be moving with a non-uniform velocity. This is about the velocity, average velocity, instantaneous velocity, uniform velocity, and non-uniform velocity. Now we do some problems regarding this average velocity. For example, a body traveled from A to B, then returns to A with velocity v1, and the return journey is with v2. What is the average velocity of this body? Here the displacement, net displacement is 0 here. Net displacement is 0 here, because initial and final position of a body is A. That is why average speed, average velocity is equal to 0 by time. That means 0. 0. Next one. We do another problem, for example, average speed and average velocity. Now these are over, about these terms are over. Now we will do some examples regarding the average speed and average velocity. For example, here there is a clock, there is a seconds hand of length 4 meter. In 15 seconds it reaches this point. What is the distance traveled by the tip of the seconds hand? What is the distance traveled? What is the displacement covered by the tip of the seconds hand? What is the average speed and the average velocity we want to find out? Thus, here in 15 seconds it reaches this point. Seconds and 15 seconds it reaches this point. Distance delta S is equal to how much here? Pi r by 2 pi r by 4, that means pi r by 2. What is the radius? That is the length of the seconds hand. Here 4 by 2, 2 pi I think. 2 pi. That is the distance traveled. Now the total distance traveled is that much. The average speed is equal to total distance by total time. That means 2 pi by 15. 2 pi by 15. Pi by 15. What is the 2 pi r by 4? Here this 1/4 of the circumference, 2 pi r by 4. Pi r by 2. 4 by 2, 2 pi, okay, 2 pi by 60, 50 centimeter per second. Another way, average velocity or displacement traveled by the tip of the seconds hand, delta r bar mod is equal to, it is r, it is r, it is the hypotenuse, this is the displacement, delta r bar. Here it becomes r square plus r square square root of, that means square root of 4 square plus 4 square, 4 root 2 meters. This is the displacement traveled by the tip of the pin, seconds hand. Next one, average velocity is equal to delta r bar by delta t. It becomes 4 root 2 by, this is the displacement, 15, 4 root by 15 is the average velocity of the tip of the seconds hand. Now we want to find out if a particle, another example, if a particle moves along the circumference of the circle, like this, for example, a particle moves along the circumference of a circle with constant speed, v is equal to 1 centimeter per second, the radius of the circular path is 2 centimeter. Radius of the circular path is 2 centimeter. R is equal to 2 centimeter. r is equal to 2 centimeter. Then find time period 2, time period, average speed 3, average velocity. First we want to find out the time period. Time period means, for example, one revolution it covers 2 pi r. With what speed v? Now it becomes 2 pi r into by v 1. That means r means how much? 2. 4 pi seconds. Now the average speed, the total distance traveled. For example, find out the average speed in t is equal to t by 4. Here also t is equal to t by 4. G is equal to 0 to t by 4. T is equal to 0 to t by 4. Now, in this time the needle the particle travels this much of distance. We want to find out that much of distance. This is the quarter of the circle. The average speed. Pi r by 2, pi into r2 by 2 pi, by time t by 4. T means how much? 4 pi by 4. These two cancel. Pi square. T means 4 pi. T means 4 pi. 4 pi by 4, it becomes by 2 here, pi by pi. That means 1 centimeter per second. 1 centimeter. Here the speed is constant. Constant speed 1 centimeter per second square it is moving. Average velocity is equal to, here the distance travelled by a particle, displacement covered by a particle, delta r bar. Here delta r bar by delta t, modulus square root of r square plus r square by delta t, t by 4. It is root 2r by t means 4 pi by 4. 4 cancel. Root 2r is equal to 2 by pi meter per second. This is the average velocity of that particle. Average velocity of the particle. This is about the terms and some examples for the average velocity and the average speed. For example, we do one more example. If a particle travelled for a time t1 with the speed v1 and for a time t2 with the speed v2, what is the average speed of that particle? Here, average speed is equal to s1 plus s2 by t1 plus t2. It becomes v1 t1 plus v2 t2 by t1 plus t2. Total distance, s is equal to, s1 is equal to velocity into time, speed into time. This is velocity, speed into time. Total distance, total time is t1 plus t2. This is about the average speed of a body. It moves for t1 second with speed v1, for t2 second with speed v2. Okay, for this.